Hi everyone. Please be good for Miss Hearn while I'm away. So hopefully you just finished your quizzes as just a quick little review to the last 3 lessons. And now you should have that bluish teal, the blue packet. Quiz review in front of you. I'm going to go over a few questions just to hopefully make things easier for you. Help you understand what's going on. Okay, so the first one should be easy. Determine whether the relation is a function. You guys are good at that. Remember, your x or your domain does not repeat. So I'm going to leave you to your own devices on the first 6. But let's do number 7 together. So here we go. Let's read. It says the function y equals 3.5x plus 2.8x represents the cost y in dollars of a taxi ride of x miles. Okay, so we first want to identify the independent and dependent variables. So remember, your independent variable is your x, and your dependent variable is your y, right? So if we look here, what is our x, or independent variable? Well, x is the number of miles we're going. So your independent variable is miles road ridden. How long was your trip? X amount of miles. And your dependent variables, how much money are you spending, right? Your y is your cost. That's your cost in dollars. Okay. It says you have enough money to travel at most 20 miles in the taxi. Find the domain and range of the function. So I only have enough money to go 20 miles on this taxi ride, right? So I'm going to plug in 20 for our x, because that's how many miles I can go, is 20 miles, right? So here we go. So we're going to have y equals 3.5 times 20 plus 2.8. And please write this down. I know I'm doing it with you, but I think it'll be in your best interest if you write it down for your quiz on Monday, right? You're taking a quiz on Monday. So write down what I'm writing here. Now let's solve this. 3.5 times 20 is 70. Plus 2.8, 72.8. That's how much money it's going to cost us to go 20 miles. So let's see here. Our domain is our x, so how many miles, right? So what's the minimum amount of miles we can go? We don't have to go any, right? We could travel 0 miles. And the most, what's the most miles we can go? 20. So this is our domain. It is continuous like this because we could go 1.5 miles, 2 3/4 miles. That's why it's continuous like that. Now our range, well, if we went 0 miles, would it cost us any money? No. We don't have to go on a car ride at all, right? But then if we went that 20 miles, how much did it cost us? Well, we just found out it cost us $72.80. So that's our cost. So this was your miles, and here was your money, your cost. That one's kind of goofy, finding the domain and range like that. We didn't do a ton of that, so I apologize. But the rest of the front should be okay. On the next page here, finding domain and range, you guys should be okay with that. I'll give you a hint on this one. It's going to be like this, where x is in the middle and y is in the middle. So you guys have to find the numbers that go here and here and here and here. There's a number that goes there. So you guys have to figure out what these numbers are, okay? Remember, it's continuous like that because it's a curve that goes on like that, right? It's not just a bunch of dots, or these would just be ordered pairs. Okay. You guys are rock stars at linear and nonlinear. So I will leave you alone for that one. Let's go to the next one. You do number 16 together? I don't want to confuse any of you. It says the linear function y equals 1.25x represents the cost y in dollars of x bottles of orange juice. Each customer can buy a maximum of 5 bottles. Okay. It says find the domain of the function. So our domain is our input, right? Our x value. So if we look, our x is the number of bottles of juice. Well, how many bottles could we buy? We can buy up to 5, right? So we could buy 0. You could buy 1 bottle, 2 bottles, 3 bottles, 4 bottles, all the way up to 5 bottles of orange juice. That would be your domain. Now the second part of this question, is the domain continuous or discrete? So this one's kind of weird, but think about it. Can you buy partial bottles of orange juice? No, you can only buy whole bottles of orange juice, right? So it would be discrete. If you could buy partial bottles of orange juice, it would be continuous, but you can't. Just like you can't buy partial tickets to a museum, right? You can only buy whole tickets. So this would be discrete. Because you can't buy partial bottles of orange juice. Okay, 17, 18, you're just deciding if they're continuous or not. I think you'll be okay there. Evaluate, okay, now this is when you're plugging in 4 for x. You guys can do that just fine. You're just plugging in. Let's do 20 together. It's kind of goofy. 20 is a little goofy. It says, let f of t be the outside temperature degrees F, t hours after 10 a.m. Explain the meaning of each statement. Okay, this is weird. So here's our function, and it's telling us the degrees outside after t hours after 10 a.m., okay? So if I plug in 0, I'm at 0 hours, so I'm just starting. What time is it? It'd be 10 a.m., right? So that's where we're starting. So at 10 a.m., they're telling us it's 75 degrees outside. That's what that means, because it's at my starting point. I'm starting at 10 a.m., and it's 75 degrees outside. So 10 a.m., 75 degrees outside. Okay, now B is saying f of 1 is greater than f of 8. Well, what's 1 hour after 10 a.m.? So it's 11 a.m., right? Is bigger than, now 8 hours after 10 a.m.? So let's think about it. So 1 hour is 11, 12, 13, 14. Oh, geez, let's back up, you guys. I'm so sorry. All right. All right, 1 hour after 10 a.m. is 11, then 12. Now we go to 1 p.m., 2 p.m., 3 p.m., 4 p.m., 5 p.m., 6 p.m. would be 8 hours after, so 6 p.m. So that's what it means in time, but now in the context of our problem, it's the temperature. So they're saying at 11 a.m. it's warmer outside than 6 p.m. So that's what we're going to say. It is warmer outside at, let me scroll, 11 a.m. than 6 p.m. I know that one's kind of confusing too. That's what that is saying if you were to break it down. Okay, for 21 and 22, you're looking for the value of x, right? We're looking for the value of x when our function equals -4. So what you need to do, -4 equals your function, and then solve for x. So you guys need to solve that. Same thing on 22. We're looking for the value of x when it equals 8. So I have 8 equals our function, and then you solve. So you guys gotta go back and solve those, okay? Figure out what x is. Okay, on the back part, you're just making a T-chart and you're graphing. Let's just use the points you've always used. Plug these in to your function and graph away. You guys should be okay to do that. Again, it's just calculator work. Again, I would just plug in to the numbers that we've already used, -2 to 2. Should we maybe do this last one together? It says the function d of x equals 1,375 minus 110x represents the distance in miles a high-speed train is from its destination after x hours. Okay, so this is talking about the distance a train's traveling after x hours, all right? How far is the train from its destination after 8 hours? What are you going to do? You're going to plug in 8. And then solve. So you guys plug in and solve for that. Get out your answer. And it says, how long does the train travel before reaching its destination? So I'll help you set this one up. So if I'm at my destination, how far away am I from my destination? You should be there, right? Like if I'm at my destination, I don't have to travel anywhere, right? So my distance would be 0. So this would equal 0. Because I'm already at my destination. So you know you guys need to solve out how long it took you to get there. So figure out what x is, okay? All right, you have the rest of the time to work on this packet. Check your answers with Mrs. Hearn. Please be good. Stay on task, and don't forget you have a quiz on this stuff on Monday, okay? On Monday, you're taking a quiz on this information. Have a good weekend. Be good. Wear your seatbelt. And I'll see you soon. Bye.